Okay, again, let's have a look at reasoning, which is all about units of measure to do with distance and time. First off, we've got to convert these times into an equivalent but alternative unit of measure, so months to years. So if there's 12 months in a year, there must be, I'll show you on here, 5 years is 60 months, because if I do 12 times 5, I get 60. 60 divided by 12 is 5. 24 hours in a day, so how many 24s are there in 72? That's 3. Then 7 days in a week, so how many 7s in 84? Is 12. So 3, 5 and 12 as our answers to that. Next up, we're told that the International Space Station, which you may already know, there's an app that tells you when it's flying over your house, so you can go out and see it. It looks like a very slowly moving shooting star. The International Space Station orbits the Earth at a height of 250 miles, and we need to convert it into kilometres, and we're told 8 kilometres is 5 miles, roughly. It's rounded that, but that's the rough guide that we're always given. So we're going from miles to kilometres, so I'm going to divide by 5, then times by 8. 250 divided by 5 is 50. 50 times 8, well, 5 times 8 is 40. Make it 10 times more, 400. Then we've got, there we go. Ron and Annie are running a 5-mile race. And Annie has run 6.4 kilometres so far. Ron has run 3.8 miles so far. Who has the furthest left to run? So what I'm going to do is convert the miles into kilometres. Then I'll know how far Annie's still got to run. I'll convert 3.8, and then I could find the difference here and turn the answer into kilometres, or convert this to kilometres before then converting to miles. So let's have a look. 5 miles. I'm going from miles to kilometres, so I'm going to divide by 5. 5 divided by 5 is 1. 1 times 8 is 8. So now I know that they are racing 8 kilometres or 5 miles. So Annie had already run 6.4 kilometres, so she's got another 1.6 kilometres to go. Ron, we're told, has run 3.8 miles, so I'm going to do 3.8 divided by 8, decimal point in line. I'm going to convert this into kilometres so I can compare like for like. 0, that'd be 4, remainder 6, 58 into 60, excuse me, 7, 5, 6, 7, 8, 56, remainder 4, and 8 into 40 is 5. Now I need to do 0.475 multiplied by 5. Turn this right way around. Miles divided by... Oh, I've divided by 8. I should have divided by 5. Okay, try again. Run. Now to run 3.8 miles. Miles to kilometres, divide by 5. 7 remainder 3. 5 times 5. How many 5s are in 36? There we go. And then let's go over here. 0.76 multiplied by 8. So this will tell me how many kilometres Ron has run so far. 48. 56 add 4 makes 60. Okay, Ron has run. I'll carry on down here. Remember, Annie had run, or needed to run another 1.6 kilometres to go. Ron, of their 8 kilometre race, so I can find the difference to see how long he's got to go. Ron has got kilometres to go, so Ron has got the furthest to run. I feel I made that a very long-winded way around there. Excuse me. Probably took me longer to answer that question than to run the race. So now we've got to look here, and we've got a gap fill. So there are 10 millimetres in 1 centimetre. There are 100 centimetres in a metre. And there are 1,000 metres in 1 kilometre. Remember, kilo means 1,000, centi means 100. And so to convert between centimetres millimetres, we can, this is going to be 10, so times by 10 or divide by 10. We can, from metres to centimetres, we can times by 100. Metres to kilometres, going that way, we're going to divide by 1,000. And from kilometres to metres, we can times by 1,000. And we can use those rules to fill in this table. So on here, millimetres to centimetres, I'm going to divide by 10. Centimetres to metres, I'm going to times by 10. In that case, decimal point, one jump, should have 4,400. I can divide that by 100 to make 44 metres. And if I take my metres, we're about to go from metres to kilometres, we're going to divide by 1,000. So if I show you, remember, Mr. DL, decimal points hiding there, 1, 2, 3 jumps, get 0.044 kilometres. And then for the rest of the table, we're doing versions of that, working out which way. So centimetres to millimetres, I need to times it by 10, 27800. Centimetres to metres, going to divide it by 100, 27.8. Metres to kilometres, if I use my place value, look, I've got 4 tens, 4 units, 2 tens, 7 ones, so I'm going to have the same number, 0.0278. No surprise, 44 metres, 0.044. Again, in that way, 0.0155 kilometres. Metres to centimetres, going to times it by 100, so I can do 2 jumps to the right, 0 in the gap, 1,550 centimetres, and times that by 10 to turn it into millimetres. Kilometres, well, I know that 1 whole kilometre would be 1,000 metres, and that would be 750, so 1,750 metres. I can times it by 100, 1750, times it by 100 to get 175,000, which means if I times that by 10 to get 1,750,000 millimetres in 1.75 kilometres. We've got 2 more questions to go. There we go. So, Mo cycles 45 miles over the course of 3 days. Day 1, 16 kilometres. Day 2, 10 miles. How far on day 3 in both miles and kilometres? So, first off, I'm going to, for each day, I'm going to show it in kilometres and miles. Kilometres, miles, kilometres and miles. Once I know how far he's gone so far, I'm going to find the difference between how far he's got to go and how far he's cycled in both miles and kilometres. Miles to kilometres, divide by 5 is 9. 9 times 8. What does it get? 9 times 8 is 72 kilometres. 16 kilometres as miles, so I need to divide by 8 is 2 times 5 is 10 miles. Miles to kilometres, divide by 5. 10 divided by 5 is 2 times 8 is 16 miles. So, now I've not done it very well here. He's got miles and miles. So far he's done 20 miles, so he's got another 25 miles to go. So far he's ridden 32 kilometres, because 16 and 16 is 32, so he must have another 45, take away 32, mind blank. Oh, 72. I thought that was 2 more. I thought I had fewer kilometres than miles. 72 take away 32, 40. 40 kilometres to go. So final answer, 25 miles or 40 kilometres on day 3, because he cycles 45 miles, which is the same as 72 kilometres. I've worked out how far he's cycled so far on day 1 and 2 to work out what's left. And finally, table shows the time taken for school teams to complete the relay race. It's a bit like Kerber and Burbage, etc., isn't it? What I'm going to do to compare them is turn these into just seconds, and then I can find the fastest and the slowest. So 60 seconds in a minute, so I'm going to do 2 times 60 is 120, add the 5, 125 seconds. Make a note of that. And the yellows, 60 seconds, add 50 seconds, be 110 seconds. So, yellows came first, and sorry Kerber, reds came last.